Hi, my name is Lukas, and now I will be talking about our submission to the Cantemist shared task. This is joint work with my colleagues from the Bosch Center for Artificial Intelligence, Dai, Heike, and Yannick. We participated as the NLNDE team, neither language nor domain experts, and we submitted predictions to all three subtasks with a special focus on the first subtask, the extraction. Here's a short overview of our numbers, but I will tell you more in the next minutes. Let's start with the first subtask, named entity recognition. For this, we use recurrent neural networks, where the first layer is typically an embedding layer. In our submission, we use a set of multiple embeddings, including contextualized embeddings like FLAIR and BERT, but also fast text and character embeddings. The embedded input representation is then processed by the recurrent neural network, and for this we use multiple stacked bi-LSTM layers with a stacking of up to 5 layers. The LSTM output is then given to a classifier that decides which tokens belong to an entity. In our first model, we use a conditional random field classifier. This CRF treats the NER task as a sequence labeling problem and outputs a list of labels for a list of words. But we also experimented with changing specific layers of our architecture. Our first change concerns the embedding layer. Instead of concatenating the different embeddings into one big vector, we experimented with meta-embeddings that compute weighted averages of multiple embedding, and thus this reduces the overall embedding size. For this, the embeddings are mapped to the same size and then weighted using attention. Finally, the embedding vectors are summed up, resulting in the meta-embedding representation. For the third model, we exchanged the CRF classifier with a bi-affine classifier. Now the named entity recognition task is not handled as a sequence labeling problem anymore, but rather as a dependency parsing problem, which has shown significant improvements in a recent ACL paper. In addition, the bi-affine classifier is also able to detect nested entities, which also occur in this shared task, even though they are not as frequent. For the bi-affine classifier, the LSTM outputs are fed into two feed-forward networks that compute start and end representation of token spans, and then the bi-affine classifier applies bi-affine attention over these spans and computes scores for every span whether it refers to a named entity or not. As you can see in results on the test and development sets, the bi-affine classifier is our best model. We then retrained this model on the combined training and development set, which resulted in our best submission model S4. The meta-embeddings showed a higher precision in the concatenation on the development set, but this is not reflected on the test set. And we also tested an ensemble of majority voting the first three models, which increased the precision by a large margin, but due to the lower recall, this is not our best performing model in the end. For the second task, denormalization, we used a rather simple technique. We observed that there is only very little ambiguity among the named entities and their ICD codes, so we decided to use string matching whenever an entity is given that was already seen in the training data, and then we assigned a corresponding ICD code. This almost achieves perfect precision, and also the recall is okay. To further increase recall, we applied also lowercase string matching in the second step. And for all remaining unseen strings, we compute a Levenshtein distance to the known training strings, and then we select the code according to the shortest distance. As we have implemented a pipeline model for all tasks, denormalization depends directly on the extraction. And again, we see that the bi-affine model works best for this. We also submitted results for the last subtask, the ICD coding. Here we treat this as a ranking problem. We assume that ICD codes that appear more often within a document are more important for this particular document. So first we count all codes in the document, and then we rank them accordingly. Whenever two codes are mentioned equally often, we rank them by the general frequency, as observed in the complete training data. For this subtask, we see that the differences between our submissions are really small. But the training on the combined training and development set resulted at least in a small improvement. To conclude, Our best model is based on the biaffine classifier and recurrent neural networks. We achieve 85.3 F1 for the named entity recognition using this model, 76.7 F1 for the subsequent normalization using string matching and Levenshtein distance, and we achieve 74.9 map for the coding subtask using this ranking approach. Thank you very much for listening.